Okay, so in this case, what we've been presented with is a sample of sodium sulfate, right? And we've been asked to figure out, well, what's the value of X in this, right? So we've been told the mass of the hydrated sodium sulfate and the anhydrous sample of the sodium sulfate. We need to work out the value of X. So I'm going to go about that process of working it out. All right, so the formula I'm going to be using is that the number of moles N is equal to the mass divided by the molar mass, right? Now, the masses for the sodium, I'm going to use the anhydrous sample, right? Because that's the sample without the water in it, right? So, and so on that basis, I'm going to say, well, the number of moles for the Na₂SO₄ is going to be 7.54 divided by, and then what we need here is really the molar mass, right? So I need to work that out. So this is for Na₂SO₄. So the molar mass MR for Na₂SO₄, right? And so I've got some excerpts from the periodic table here. So what's relevant? So relevant is, and you know, some of them are there, but sodium, Na₂, sulfur, and oxygen, right? Na₂SO₄. So what's that going to give us? So first of all, we need the sodium, so that's going to be 23, but it's Na₂, so it's going to be times 2, times 2, plus for the sulfur, which is going to be 32.1, plus the oxygen component, which is going to be effectively 4, right? So 4 times the relative atomic mass of oxygen, which is going to be 16, right? So if you do have a go at working that out, what you should find is that gives you 142.1, right? And that's going to be in grams per mole, right? So here we're going to have 142.1, right? Okay, so if you do have a go at working that out, what you should find is that you get 0.05 3061, and that's going to be in moles. Okay, now on the we also need to look at H2O. Like, so for water, at the end of the day, what we're really comparing is the amount of substance for the sodium sulfate and the amount of substance for the water, right, in moles. So I need to work out the moles for the water as well. So, and that's going to effectively be what's it's going to be the difference between the anhydrous and the hydrated sample. So the moles here of H2O, no, well, we'll get to the moles, but we're looking at the mass first of all. So the mass of, so the mass M for H2O is going to be, so 12.04 minus 7.54, right? So these are all in grams, and if you do work that out, right, you should find that you get 4.5 grams. And so on that basis, we can now work out the number of moles for H2O. So since we have the mass, so the number of moles for H2O is equal to 4.5, right? So mass divided by molar mass. But we need the molar mass, right? So if you look to the periodic table, you've got the hydrogen and oxygen. So this H2O, so let's say, well, the molar mass for H2O is going to be effectively hydrogen times 2, 1 times 2, plus the relative atomic mass for oxygen, 16, which gives us 18, right? And that's going to be in grams per mole, right? So here we're going to have 18. Okay, so if you do work that out, you should find that you get 0.25. Okay, right. So given all of this, we can and that's going to be in moles, by the way, so that's going to be moles. Given all of this, what we want to do at this stage is compare the moles for the Na₂SO₄ and the H2O, right? To really get closer to the question of answering the question of, well, for every 1 mole of Na₂SO₄, how many moles of H2O? So, you know, Na₂SO₄ here, we can see it's on the left hand side, H2O is on the right, so I'm going to kind of follow the same convention here. So number of moles of Na₂SO₄, number of moles of H2O, right? And so on this side, we're going to have 0.053061, the ratio of 0.25. Okay, and as I said, really we're asking for every 1 mole of Na₂SO₄. Here, clearly this is not 1, so we want to get this value on the left hand side to be 1. And the way we're going to do that is by dividing it by itself, right? So if we divide it by itself, we're going to get dividing it by 0.053061, right? And if we do that on to the other side as well, divide it by 0.053061, what we're going to get on this side is 1, right? And that's going to be in ratio with, if you do run that calculation, you should find that you get 4.7116, right? Now 4.7116 rounds upwards to 5, okay? And why that's relevant is because what we want is an integer value for x, right? So we do have to round this to the closest integer, which is 5. So what we can say is that, well, this is in effect 1 in a ratio with approximately 5, right? And so we can say therefore x is equal to 5, and therefore the formula, well, I don't have to write therefore at this stage, but the formula is going to be Na₂SO₄.5 H2O, okay? And so given x is 5, and we've been asked to provide the answer in the space here, I can just provide that. That is going to be 5, okay?